All right, now we're ready to solve inequalities using the sign of a function. So I've got a bunch of steps here. I recommend writing all of these down, but to explain how to use them, I'm going to complete an example at the same time. Pause the video anytime you need to get something down. Now, the first step, arrange your inequality so that one side equals 0. So over here, one side equals 0. That doesn't mean I need an equal sign in my inequality. It's still an inequality, but one side has nothing on it. Everything's on the other side, so I'm ready to go. Some of the ones we look at won't be that way and we'll need to fix them up. Then I need to consider the function y equals, and now I've sort of awkwardly written here, y equals the side that contains the terms. What I mean by that is I need to consider y equals everything that's on this left-hand side. Because, as we've already seen, if I can graph y equals all of this, and I can graph y equals 0, which is just the x-axis, I'm going to have a curvy line for y equals all of this, and I'm going to have a straight line for y equals that, and I'll be able to just see where my curvy line dips below the other line. And that's the strategy here that we're using. So I want to consider y equals all of that so that I can graph it in 2 dimensions. Even though there's no y's in my question, I'm bringing it in to help me. Now, second step, spot any zeros or x-intercepts and look for discontinuities. Now this one doesn't have any discontinuities. I can tell because x can be anything here and I can complete these steps with it, and y can also be anything I like. It's a cubic curve and I can tell that because it's got x times x times x in it if I expand it right out. It's also positive, so I know it's going to have this basic sort of shape like this, maybe a bit wobbly. So I've sort of got that in my mind. Now it's going to go through the x-axis 3 times because if I let y equal 0, then obviously I'm going to have 0 equal to all of this. And that means if I have something times something else, and I get 0, one of these must have been 0. And that will only happen if this part's 0, where x is 1, or if this is 0, x would have to be 3 to make that happen, or if x was 5. So that's what you could probably think that part through in your head. I'm literally going to jump straight in here to save myself some board space and say x equals 1, 3, or 5. They're my intercepts. Okay, next I'm going to make a table of values. So I'm going to consider when x is a bunch of things, what will y be? Now it says to use the x values that you found in that's step 2. So I'm going to use these x values. I'm going to want 1 and 3. Oops. Let me do this again. I'm going to want 1 and 3 and 5. But I also want some more than that. I want a point on either side. So I want to see what happens below 1 and between the 1 and the 3, between the 3 and the 5 and above the 5. So I need all these points. Now pick yourself a nice simple number. What's below 1? I'm going to use 0. Between 1 and 3, 2. Between 3 and 5, 4. And 6. Now if I put these in and actually calculate what the y value would be, and you don't need to expand it out, simply sub 0 in here. 0 minus 1 is minus 1, times minus 3, that will give me 3, times minus 5, that will give me negative 15. If I sub 1 in, obviously, or 3 in, or 5 in, they're called zeros, those x-intercepts, because when you sub them into the function, you get 0. If I sub in 2, I've got 2 minus 1, that's 1, times negative 1, that's negative 1, times negative 3. So that would give me 3. And if I sub 4 in, I'm going to get minus 3, and subbing in 6 gives me 15. All right, I've done this step. Step 4, add a third line for the sign of y. All right, nice and simple here. We're just going to put another line in our table of values and call it the sign. Now, just have a look and see which of these numbers are 0. Obviously, the zeros are 0. Here I've got negative, positive, negative, positive. So that really gives me a good indication of how this thing is going to be graphed. I had a bit of an idea of the shape in the beginning, and now I know where it goes through. Make a quick sketch of the function. All right, I know it goes through 1, 3, and 5, and when it's at 1, 3, and 5, it's on the line. But when it's this side of the 1, it's negative, so it's down here, isn't it? And then it's positive when it goes back to 0 again. It must do something of a loop like that. And then it's negative when it's between 3 and 5, so it's down here, but it comes back to 0 again, so it must loop back up, and then it's positive. That gives me my quick sketch of y equals all of this. Now, step 6, highlight the parts above or below the x-axis. The x values of the highlighted section are the solutions to the inequality. So, taking your pen, or you could take another colour, have a look again and see what we want. This is a curvy line. This is a straight line, the line y equals 0. It goes straight across there. It's on the x-axis. So we want the parts where our curvy function are less than or lower than the x-axis. Well, we're lower than the x-axis when we're down here. I like to just sort of scribble on it, make it nice and heavy so it's really obvious to me. And we're below the line when we're here. So what x values equate to those parts? Well, x is less than 1, or x is between 3 and 5. Now, consider whether 1, 3 and 5 might be part of our answer. No, they're not part of it, because we only want the bits that are less than 0, not the bits that are equal to 0. So that tells you what to do. So now the answers then, I'll just use this bit of the board here to put my answer in, would be x is less than 1, or x is between 5 and 3. Now, we've just learned how to write that using our new notation. We've got a union here of two sets, don't we? They don't overlap, they're either one or the other. So if x is less than 1, then it's going from negative infinity, comma, to 1, and it's not including 1, so we can use round brackets for both of them. And we have a union of this part and this part here. Now, both of these are not included, so we've got round brackets, 3, 5. So once you start using this notation, you'll realise it can be quite nice and quick to express your answer that way. You won't be marked down if you express it like this, but you need to understand that you can express it this way and you might see it in a question.